According to the National Electrical Code, NEC Section 110.26a, electrical equipment shall not be installed in locations where it may be exposed to excessive moisture unless the equipment is enclosed in a suitable waterproof or weatherproof enclosure. Section 408.33 states that main circuit breakers shall not be located in bathrooms. The rationale behind this is that bathrooms are typically humid environments, which can damage electrical equipment and create a safety hazard. The NEC requires main circuit breakers to be readily accessible for emergency disconnect, and a bathroom is not considered a suitable location for this purpose. Therefore, a main circuit breaker panel cannot be enclosed in a waterproof panel and remain in a bathroom. Possible solutions include moving the circuit breaker panel, relocating the panel to a garage or another accessible location outside the bathroom. Another option is to create a closet outside the bathroom where the panel can be located securely and accessible. One other option includes installing a separate subpanel within the bathroom for the branch circuits in that room, but locating the main circuit breaker panel elsewhere. It is important to note that any changes to the electrical system must be performed by a licensed electrician and in accordance with the NEC. The NEC provides specific guidelines regarding working clearances around electrical equipment. These clearances ensure that electricians and other qualified personnel have sufficient space to safely install, maintain, and operate electrical equipment. The required working clearances depend on the voltage of the equipment and the presence of exposed live parts. For equipment operating at 600 volts or less, the NEC specifies minimum working distances from the front of the equipment to any grounded surface or other obstruction. These distances vary depending on the voltage and the condition of the opposing surface. Condition 1 exists where there are exposed live parts on one side of the working space and no grounded parts or grounded parts insulated on the other side of the working space. Condition 2 exists where there are exposed live parts on one side of the working space and grounded parts on the other side of the working space. Condition 3 exists where there are exposed live parts on both sides of the working space. The NEC also requires that the working space be clear and unobstructed. This means that there should be no storage of materials, equipment, or other items in the working space. The working space should also be adequately lit to allow for safe and effective work. In addition to working clearances, the NEC also specifies requirements for access to electrical equipment. Access pathways must be of sufficient size and clear of obstructions to allow personnel to safely reach and work on the equipment. The NEC also addresses the issue of dedicated equipment space. This refers to the space above and below electrical equipment that must be kept clear of any foreign systems such as plumbing, HVAC, or other non-electrical equipment. The purpose of dedicated equipment space is to protect electrical equipment from damage and to ensure that it is readily accessible for maintenance and repairs. The NEC also has specific requirements for the installation of electrical panels in damp or wet locations. In such locations, a panel must be installed in a weatherproof enclosure to protect it from moisture. The enclosure must be designed to prevent water from entering and damaging the electrical components. The NEC also requires that the panel be mounted in a way that prevents water from accumulating around it. This may involve raising the panel off the floor or providing a drainage system to remove any water that may accumulate. Furthermore, the NEC addresses the grounding and bonding of electrical panels. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow. Bonding is the process of connecting different metal parts of the electrical system together to create a low impedance path for fault current. Proper grounding and bonding are essential for electrical safety because they help to prevent electric shock and fire hazards. The NEC specifies the types of grounding and bonding conductors that must be used and the methods for installing them. Additionally, the NEC addresses the labeling of electrical panels. Each panel must be clearly labeled to identify the circuits that it serves. The labels must be durable and easy to read. They should also be updated whenever changes are made to the electrical system. This helps to ensure that electricians and other qualified personnel can quickly and easily identify the correct circuits when performing maintenance or repairs. When determining the appropriate size of a circuit breaker panel for a residential application, several factors must be considered. These factors include the total load of all the circuits that will be connected to the panel, the diversity factor of the load, and the anticipated future load growth. The total load is the sum of the amperage ratings of all the devices and appliances that will be connected to the panel. The diversity factor is a percentage that takes into account the fact that not all of the devices and appliances will be operating at the same time. The NEC provides tables that can be used to determine the appropriate diversity factor for different types of loads. Future load growth should also be considered when sizing a circuit breaker panel. It is always a good idea to choose a panel that is large enough to accommodate any anticipated future load increases. This will help to avoid the need to replace the panel in the future. It is also important to consider the physical size of the circuit breaker panel when choosing a location for it. The panel should be installed in a location that is readily accessible and has sufficient space for working around it. The NEC specifies minimum working clearances around electrical equipment, and these clearances must be maintained. In addition to the NEC requirements, there may also be local codes and regulations that apply to the installation of circuit breaker panels. It is important to check with the local building department to determine what these requirements are. The NEC provides guidelines on the use of arc fault circuit interrupters, or SIs. SIs are circuit breakers that are designed to protect against fires caused by electrical arcs. Arcs can occur when there is a break in the insulation of a wire, allowing current to flow through the air to a grounded surface. SIs are required in many circuits in residential occupancies, including those that serve bedrooms, living rooms, and dining rooms. The NEC specifies the types of circuits that require SI protection and the methods for installing them. It is important to follow these requirements to ensure that the electrical system is safe and protected against fire hazards. Ground fault circuit interrupters, or GFCIs, are another type of circuit breaker that are designed to protect against electric shock. GFCIs work by monitoring the current flowing in a circuit and detecting any imbalance between the hot and neutral conductors. If an imbalance is detected, the GFCI will trip the circuit, cutting off the power and preventing an electric shock. GFCIs are required in many locations in residential occupancies, including bathrooms, kitchens, and outdoor areas. The NEC specifies the types of locations that require GFCI protection and the methods for installing them. It is important to follow these requirements to ensure that the electrical system is safe and protected against electric shock. The NEC provides guidelines on the use of surge protective devices, or SPDs. SPD are devices that are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power grid switching. SPD work by diverting the surge current to ground, preventing it from damaging the electrical equipment. SPD are available in a variety of types and sizes, and they can be installed at the service entrance, at the panel board, or at individual pieces of equipment. The NEC specifies the types of SPD that are appropriate for different applications and the methods for installing them. It is important to follow these requirements to ensure that the electrical system is protected against voltage surges. The NEC provides guidelines on the proper wiring methods for electrical circuits. These guidelines cover topics such as the types of conductors that can be used, the ampacity of conductors, the methods for protecting conductors from physical damage, and the methods for terminating conductors. The NEC also specifies the types of wiring devices that can be used, such as receptacles, switches, and lighting fixtures. It is important to follow these requirements to ensure that the electrical system is safe and reliable. The NEC provides guidelines on the proper grounding and bonding of electrical systems. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow. Bonding is the process of connecting different metal parts of the electrical system together to create a low impedance path for fault current. Proper grounding and bonding are essential for electrical safety because they help to prevent electric shock and fire hazards. The NEC specifies the types of grounding and bonding conductors that must be used and the methods for installing them. The NEC provides guidelines on the proper installation of electrical equipment. These guidelines cover topics such as the location of equipment, the mounting of equipment, the ventilation of equipment, and the protection of equipment from physical damage. The NEC also specifies the types of enclosures that must be used for different types of equipment. It is important to follow these requirements to ensure that the electrical equipment is installed safely and correctly. The NEC provides guidelines on the proper maintenance of electrical systems. These guidelines cover topics such as the inspection of equipment, the testing of equipment, the cleaning of equipment, and the repair of equipment. The NEC also specifies the types of records that must be kept for electrical systems. It is important to follow these requirements to ensure that the electrical system is properly maintained and that any problems are identified and corrected in a timely manner. The NEC is a complex document, and it is important to have a thorough understanding of its requirements before working on any electrical system. It is also important to stay up to date on the latest changes to the NEC, as it is revised every 3 years. The NEC provides a comprehensive set of guidelines for the safe and reliable installation, operation, and maintenance of electrical systems. By following these guidelines, electricians and other qualified personnel can help to ensure that electrical systems are safe and protected against hazards. The specific requirements for circuit breaker panel installations can vary depending on the local jurisdiction. It is essential to consult with the local building department and a licensed electrician to ensure that all applicable codes and regulations are followed. This includes obtaining the necessary permits and inspections. Failure to comply with local codes and regulations can result in fines, penalties, and even legal action. In addition to the NEC, there may be other industry standards and best practices that should be followed when installing circuit breaker panels. These standards and best practices can help to ensure that the electrical system is safe, reliable, and efficient. Some examples of industry standards and best practices include using high-quality materials, following manufacturers' instructions, and performing thorough testing and commissioning. It is important to stay informed about these standards and best practices and to incorporate them into your work. When working on electrical systems, it is always important to prioritize safety. Electrical work can be dangerous, and it is essential to take precautions to protect yourself from electric shock, arc flash, and other hazards. Some basic safety precautions include wearing appropriate personal protective equipment, such as safety glasses and gloves, de-energizing circuits before working on them, and using insulated tools. It is also important to be aware of the potential hazards in the work area and to take steps to mitigate them. If you are not comfortable working on electrical systems, it is best to hire a licensed electrician. A licensed electrician has the training, experience, and knowledge to safely and correctly install, repair, and maintain electrical systems. Hiring a licensed electrician can help to ensure that the electrical system is safe, reliable, and compliant with all applicable codes and regulations. The NEC addresses the issue of voltage drop in electrical circuits. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause electrical equipment to malfunction or fail. The NEC specifies the maximum allowable voltage drop for different types of circuits. It also provides guidelines on how to calculate voltage drop and how to select conductors that are large enough to minimize voltage drop. It is important to consider voltage drop when designing electrical circuits to ensure that the equipment will operate properly. The NEC provides guidelines on the use of electrical boxes. Electrical boxes are used to enclose and protect electrical wiring and devices. The NEC specifies the types of electrical boxes that can be used in different locations and the methods for installing them. It also specifies the minimum size of electrical boxes based on the number and size of conductors that will be installed in them. It is important to use the correct type and size of electrical box to ensure that the wiring and devices are properly protected. The NEC provides guidelines on the use of flexible metal conduit, or FMC. FMC is a type of flexible metal tubing that is used to protect electrical wiring. The NEC specifies the types of locations where FMC can be used and the methods for installing it. It also specifies the maximum length of FMC runs and the requirements for supporting FMC. It is important to follow these requirements to ensure that the wiring is properly protected and that the FMC is installed safely. The NEC provides guidelines on the use of liquid-tight flexible metal conduit, or LFMC. LFMC is a type of flexible metal tubing that is designed to be watertight. The NEC specifies the types of locations where LFMC can be used and the methods for installing it. It also specifies the maximum length of LFMC runs and the requirements for supporting LFMC. It is important to follow these requirements to ensure that the wiring is properly protected from moisture and that the LFMC is installed safely. The NEC provides guidelines on the use of non-metallic conduit, such as PVC conduit. PVC conduit is a type of plastic tubing that is used to protect electrical wiring. The NEC specifies the types of locations where PVC conduit can be used and the methods for installing it. It also specifies the requirements for supporting PVC conduit and for protecting it from physical damage. It is important to follow these requirements to ensure that the wiring is properly protected and that the PVC conduit is installed safely. The NEC provides guidelines on the use of cable trays. Cable trays are used to support and route electrical cables. The NEC specifies the types of cable trays that can be used in different locations and the methods for installing them. It also specifies the requirements for supporting cable trays and for protecting cables from physical damage. It is important to follow these requirements to ensure that the cables are properly supported and protected. The NEC provides guidelines on the use of wireways. Wireways are metal enclosures that are used to protect and route electrical wiring. The NEC specifies the types of wireways that can be used in different locations and the methods for installing them. It also specifies the requirements for supporting wireways and for protecting cables from physical damage. It is important to follow these requirements to ensure that the wiring is properly protected and that the wireways are installed safely. The NEC provides guidelines on the use of auxiliary gutters. Auxiliary gutters are metal enclosures that are used to supplement the wiring space in electrical equipment. The NEC specifies the types of auxiliary gutters that can be used in different locations and the methods for installing them. It also specifies the requirements for supporting auxiliary gutters and for protecting cables from physical damage. It is important to follow these requirements to ensure that the wiring is properly protected and that the auxiliary gutters are installed safely. The NEC provides guidelines on the use of pull boxes and junction boxes. Pull boxes and junction boxes are used to provide access to electrical wiring for pulling, splicing, and terminating conductors. The NEC specifies the types of pull boxes and junction boxes that can be used in different locations and the methods for installing them. It also specifies the minimum size of pull boxes and junction boxes based on the number and size of conductors that will be installed in them. It is important to use the correct type and size of pull box or junction box to ensure that the wiring is properly accessible and protected. The NEC provides guidelines on the use of terminal blocks. Terminal blocks are used to connect electrical wires together. The NEC specifies the types of terminal blocks that can be used in different locations and the methods for installing them. It also specifies the requirements for torquing terminal screws and for labeling terminal blocks. It is important to use the correct type of terminal block and to install it properly to ensure that the wiring connections are secure and reliable. The NEC provides guidelines on the use of wire connectors. Wire connectors are used to join electrical wires together. The NEC specifies the types of wire connectors that can be used in different locations and the methods for installing them. It also specifies the requirements for torquing wire connector screws and for insulating wire connectors. It is important to use the correct type of wire connector and to install it properly to ensure that the wiring connections are secure and reliable.